case you notice I didn't want you to use a calculator here. What we're trying to show is this radical expression with a bunch of large squares is always going to be a positive integer. Okay, no fractions. It's just going to reduce to a positive integer. Most people would say simplify. I like these instructions more. Now, one thing to notice right here that really gives this thing some structure, since it is three terms, you would have, what do we got here? We have 3,000, and this is, if you notice this, you may get the hint that a algebraic identity is going to come in to rescue us. And indeed, if you subtract 2809, which is the base of this middle exponential, from 3097, which is the base of the first exponential there, you do get 288. Now that's a nice catch, because it turns out you can do some algebra on it, which essentially does almost all the work for you. So let's go down and check out what that might be. You know, because you could call this a squared. This looks like a minus b squared, and this looks like b squared, right? With these, after you notice this difference here. Okay, so let's go on down. And sure enough, that's what I did for you, save you the trouble having to watch me do it. But when you do all that, you get a lot of nice simplifications, not surprisingly, and you get this expression right here. Okay, this looks nice. So we're we're hoping that 2 times b times a, we're hoping that both of these factors in the radicand are perfect squares. Okay, so if we make the assumption, the natural assumption here, b is equal to 288. Okay, and it's pretty obvious, you know, I'll write it down anyway. And then a is 3097. Okay, a is 3097. Okay, this is what happens. Okay, and again, all I did here is I just wrote it down. Here's the substitutions. If you trust the algebra, we got down to this step right here. So this 2 that you see right here is the 2 that you see right there, of course. Okay. Now watch what happens here. We caught a break here because, let's see here, what do we get here? This would be equal to, let's go over here, the square root of 576. 2 times 88 is 576. And you guys, a lot of you know, probably that's a small enough square. That's 24 squared. Then I think this one here, what would this be? 2809. 2809. So this would be times 2809. So we already know, if you've been around numbers very much at all, you know that 24 times 24 is 576. That's an easy multiply. 2809 is not quite as clear. So let's take a look at how we might narrow this down. We do know that 2809 would be trapped between 50 squared, right? If 2809 is a perfect square, which we're hoping, and these things are designed to work out, of course. Okay, it would be between 50 squared and even, you could say 55 squared pretty easily, right? I think. But if you don't want to trust that, just say, 60 squared. Okay, so that's 3,600. This is 2,500. So 209 is definitely in there. Now, since this ends in 9, there's only 2 possibilities. That would be either 53 squared, right? 53 squared would end in a 9. Or 57, right? Those are the only possibilities. Those are the only values. This is how you can save yourself a lot of work. All right, and you'll probably notice that 57 squared is too large, just almost by mental math. So it turns out that 53 squared is equal to this. And again, you can verify that however you want. But in any event, what we get right here is the square root of 24 squared times 53 squared. Okay, so square rooting and squaring are inverse operations. And so we see that this is equal to 24 times 53. And a fairly simple multiplication, I won't do that one for you, 24 times 53, but that's manageable, right? Much more manageable than the original expression. This is equal to 1272. Okay, so that's our solution, folks. 1272 is the answer. And again, just an algebraic identity is what did the work. When you first look at this, it looks impossible, but then this structure, this simple piece of structure here, leads to a lot of cancellation and a manageable result. And again, notice it's not guaranteed to be a natural number. It has to be the case that both 2b and a minus b are perfect squares. That's the only possibility. So the problem was kind of designed to work out that way. Otherwise, it would just be an irrational number. But anyway, it is a member of the natural numbers since it's equal to 1272. It's equal to, let me write this. It's equal to 1272, which is a proud member of the natural numbers. Okay, good day.